Everyone. Talking to you again from the playroom of Georgia Grace Frankovic in Washington, D.C. We are talking today about valence electrons, and we're actually going to look at some Lewis electron-dot structures. This should be a fairly quick introduction to valence electrons. First of all, we've talked about valence electrons a couple times, but I just want to make sure that we have a specific definition here for you guys. Valence electrons are the electrons that are in the atom's outermost orbitals. All right, so we have inner electrons that are shielded by these outer valence electrons, and I'll show you a diagram in a second. These outermost electrons are the electrons that participate in chemical bonding. Remember from the last video I had said that the inner electrons are shielded. That means that they're not really able to participate in chemical bonding. So these valence electrons are the important ones that we're looking to see how an atom is going to react with another atom. These valence electrons also determine the chemical properties of an element. All right, so remember that we said that protons are the identity of an atom. The electrons are the personality of the atom, how they're going to react with each other, and specifically these valence electrons. Now, we can use the periodic table to determine how many valence electrons an atom has. We use that by looking at the column number on the periodic table, and I'll show you that in a second too. Now, I have a little diagram, a Bohr model of phosphorus, an atom of phosphorus. Phosphorus has 15 protons and 15 neutrons in its nucleus. Phosphorus is right here, right? So it's in the third energy level, 1, 2, 3. So right here we can see that phosphorus has 3 energy levels, 1, 2, 3. It has 15 electrons, right? Because that's how many protons it has too. So neutral phosphorus has 15 electrons. So if we were to draw this in a Bohr model, the first energy level can hold 2 electrons. The second can hold up to 8, so we have 8 there. And then the remaining 5 electrons go in that third energy level. The electrons in the first and second energy levels, those are our inner electrons. Those are the ones that are shielded by our outermost electrons. So the electrons in the outermost orbital are called our valence electrons, right? So we have 3 here and 2 here. Phosphorus has 5 valence electrons. Now, how do we know that just from looking at the periodic table? Well, I said here, we can look at the column number on the periodic table. I've actually labeled this one for you so that you can see. I want you to label this on your own periodic table that I had you, or that the sub had you put in your notes, right? So our very first column here, we call this a group or a family. The very first column has 1 valence electron. The next column has 2 valence electrons. We skip our D block and we come over to the P. Remember that the S and the P blocks are always going to have our valence electrons, all right? Valence electrons will only ever be in the S and the P, never in the D or the F blocks, right? So 1 valence electron, 2 valence electrons. Over here, starting with boron, this group or family, column, has 3 valence electrons. Carbon's group has 4. Nitrogen's group has 5. Oxygen's group has 6. Fluorine's group has 7. So all of these are called halogens. All of these halogens have 7 valence electrons. All of these noble gases have 8. The exception being here, helium, right? It only has 2 electrons, so it can't have 8 valence electrons. So helium is happy with only 2 valence electrons. We can see that the first energy level only holds 2 valence electrons. At 2, it's full, right? So helium is still a noble gas with a full valence shell, but its first energy level is full with only 2 electrons. Hydrogen, same kind of deal. We see over here, it only has 1 valence electron. It is in the first group. Technically, helium belongs right here as an S2, right? Hydrogen is 1s1. Helium is actually 1s2. So it has 2 valence electrons, even though it's in our group of 8 valence electrons. Right? So that's how you can tell using the periodic table how many valence electrons an atom has. Now, we're going to look at how to draw Lewis electron-dot structures for any of the elements really that we see on the periodic table. We're going to use their valence electrons to do this. All right, so what Lewis electron-dot structures show is the chemical symbol of an atom surrounded by the number of valence electrons. We know how to find the chemical symbol on the periodic table. We know how to find now the number of valence electrons on the periodic table. So we can draw a Lewis electron-dot structure. How do we do this? The very first thing is we're going to put the chemical symbol in the middle, right? So this is a chemical symbol surrounded by the valence electrons. We need to put the chemical symbol in the middle. Down here for oxygen, right? We can find oxygen here. The chemical symbol, you should all know anyway, is O. So I'm going to put O in the middle here, okay? The first 2 electrons are going to pair on the right. So if the atom has at least 2 electrons, they're going to be drawn paired on the right side of the atom. After that, we're going to add electrons singly, one at a time. We're not going to pair them yet. We're going to add them singly, top, left, bottom. So they're going to go top, left, bottom, one at a time before they double. If they have to double, then we'll double, top, then left, then bottom. Let's see how this works. We're looking at oxygen, which we can see on the periodic table is right here. It's in group 6, right? So it has 6 valence electrons. 6 valence electrons. We need to draw those in. The first 2 electrons are paired on the right. Here's 1, 2, right? That would be considered our first filled energy level, right? If we're looking at helium. So 1, 2. Now the next electrons are going to add singly, top, left, bottom. I have 2. Here's 3. Left is 4. Bottom is 5. We need 6 valence electrons, so 1 more. We're going to double up at the top. 6, right? So double at the right, then singly, top, left, bottom, top, left, bottom. We can hold a max of 8 valence electrons. So I'm going to put here max 8 valence electrons, right? So you should never have more than 8 valence electrons drawn. If we're looking at our periodic table, our columns show the number of valence electrons. We don't go any higher than 8, all right? So we can't show more than 8 valence electrons, all right? I'm going to do one more, all right? If we're looking at chlorine here, I'm going to do chlorine. Chlorine is right here. Cl is the chemical symbol. What column is it in? The column of halogens, which have 7 valence electrons. So 7 valence electrons, we need to draw those in. Our first 2, there's at least 2, right? There's 7. Our first 2 pair at the right, and then top, left, bottom, top, left, bottom. So there's 2, now we have 3, 4, 5, 6, 7 valence electrons. So there's only 1 unpaired electron in chlorine. That's it for Lewis electron-dot structures and determining the number of valence electrons using the periodic table. We will practice this in class on Friday. I will be in class on Friday with you guys to practice everything about electrons that I've missed over the past few days. See you all in a couple days.